Okay, hi everyone. Today I'll be talking about GPS RTK technology and its applications in agriculture. First of all, let me explain briefly and simplifying how this technology works. So in the picture you can see what a standard GPS looks like the one you have on your smartphone. It will provide you around 2-3 meter accuracy in optimal conditions. It's interesting that if you take two of these standard GPS receivers and you put them, let's say, nearby let's say inside a 30-kilometer radius, both GPS receivers, they will have this standard accuracy, but the error is going to be in the same way, as you can see here. If one of these receivers is installed in a location from which we know its coordinates, okay, we can use this to send some correction data to the other GPS receiver, okay, in order to get a centimeter accuracy. Okay, we are talking about 1-2 centimeters. So this is more or less how it works, simplifying this. And just to give you an idea, this is the location of all the base stations from the Instituto Geográfico Nacional in Spain. And these are base stations free to use. Okay, and as you can see, they cover completely the whole area of Spain. But if you want to use this technology in a place where there is no such network, you can also install your own base station. Okay, so let's talk about how to apply this technology in agriculture. The main application, I would say, is auto guidance for heavy machinery or tractors. Okay, this is basically you put this GPS on a tractor, you put a small motor on the steering wheel, and since the tractor knows exactly its location and you can put the coordinates of your field, the tractor can move automatically. Okay, and how can this, so what's the advantage of having this? I will use a very simplified example to explain this. Imagine you have a cornfield and you need to apply herbicide. Okay, here you can see the tractor and the application tool, and ideally, if you have a rectangular field, the tractor would just move along the field, applying the herbicide product. This is ideally, but depending on the length of this tool and depending also on the visibility conditions and so on, since you are steering the tractor manually, you need to put some overlap because you don't want to miss any spots. Okay, and we are talking about 30-50 centimeters, again, depending on the size of the tool. If you use this GPS technology with the tractor, since it knows exactly its location, you can reduce this overlap to less than 5 centimeters. Okay? But in the real world, fields are not rectangular usually. They have strange shapes, like in this example here. So in this case, what you would usually do is first you would drive the tractor along the perimeter of the field, and then you would just do rows to complete, okay? And the driver of the tractor, he can turn on or off this application tool. So, and you will not only have this huge overlap, but you would have this other overlap because of the irregular shape of the field. With RTK technology, not only you are reducing the overlap, but there are some tools that you can control individually the nozzles of the herbicide or pesticide application or fertilizer. So as the tractor moves along the way, it will automatically turn on or off the nozzles to reduce this extra overlap. Okay, and in addition to this, if we go back to this slide, this is just a simplified example, but you can see that the tractor, apart from the perimeter round, it needs 5 rows to cover completely the field, while using RTK technology and automatic guidance, in 4 rows, you complete the field completely, with almost no overlap. In addition to this, if you combine a satellite or drone imagery, you can detect in which parts of this field you need to apply more or less herbicide, pesticide, or fertilizer. And maybe there are some areas that you don't need to apply it at all, okay, because the crop is healthy there. So if you combine this information with variable rate nozzles, you can apply exactly the optimum amount of product that your field needs. And well, the advantages are obvious. You are saving fuel because you need to do less passes on the field. You save on herbicide product. All this has an economic impact. You don't do overdosage on the field. You don't miss any spots. Okay, imagine you are driving a tractor for 10 hours in a large, very large field, and you don't have any reference. It's extremely easy to forget where have you been, and maybe you say, okay, just in case, let me go again in this area because I'm not pretty sure, and you are applying some extra overdosage to this. And all this means that you have better productivity, quality, and traceability because you know exactly where you have been. You can generate automatic reports for that. Since a tractor will always go following the same path, you will also reduce land compactation and improve soil health. And of course, the tractor drives alone, so the operator will have less fatigue. Okay? And this was just an example for herbicide, but when you are growing a crop, there are other mechanized tasks, and not all of them can take the same advantage, but the benefits are at least similar to this herbicide application. And let me talk briefly about other interesting applications of this technology. This one is a very hot one, robotics and drones. So it's basically unmanned machinery like the tractor, but usually with the tractor, you will want to have someone on the tractor for safety reasons or if something fails. But these are completely automatic machines. In this example, you can see a machine that removes weeds automatically without applying any herbicide by mechanical means. You can also use this technology when you have some technician on the field for crop scouting, so he can take a look at which areas of the field require some extra fertilizer or if there are some pests, and they can geolocate with centimeter accuracy level where this is happening. So then he can put this information on the computer and then the machinery works alone. And there are other applications. This one is maybe not so attractive, but land tenure, boundaries, and cadastre, especially in underdeveloped countries. This is a big issue because farmers, they don't know exactly where their land starts and when it ends. So there are a lot of conflicts, and they are starting to invest on these kind of applications. You can also do optimized planting, plant every tree exactly where you want, land leveling, etc. Okay. Yeah.
Thank you very much.
No, I'm not done.
Oh,
sorry.
I have.
Still have 1 minute. Last
20
slide.
seconds left.
Yes. Yes.
Before.
So this technology may seem something of the future, but it's actually a pretty old technology. The first commercial RTK receiver was released in the 1990s. But it was extremely expensive. Only a few companies built them. So if you had a tractor from one brand, you could only buy the GPS receiver from the same brand and also getting corrections from the same brand. So everything was very expensive, and it was only worthy for very big farms. But since 2018, a new batch of low-cost RTK receivers with exactly the same accuracy is on the market. They are brand agnostic. You can make them compatible with any kind of accessories, and you can retrofit all machinery. Okay, you don't need to spend 100K on a new tractor to do this. You can take your 1950 tractors and with 2,000 euros investment, you can make it go automatically. Okay, here you have some numbers, and I brought one of the receivers. So this is a 150 euro RTK GPS receiver. Okay, with the antenna, it's another 50 euros. And with this, you get exactly the same accuracy as with these high-end receivers. Thank you very much.